we're going to be talking about automating visualizations with large language models. Before we do that though, I have a quick, not quite a quiz, just a few questions, just so I can gauge where I pitch this talk. Please raise your hands if you've used ChatGPT or any LLM. Okay, I should turn that around. Please raise your hands if you have not used ChatGPT, Gemini, Anthropic. Okay, so nobody's missed that bandwagon. Yeah, no, I was curious. How many of you have written programs or any code using ChatGPT or any LLM? Okay, that's still about, okay, how many of you have not written code? Okay, that's one, got it. How many of you have uploaded a spreadsheet or any data set to ChatGPT or any other LLM and asked it to do the analysis? Yeah, that's about 15 or so. Got you. That is helpful. How many of you have written a program that will call a large language model API, like an OpenAI API or a Gemini API or an Anthropic one? Okay, it's about 6 or so. Thank you. Good. That tells me where I need to, well, what I need to cover and how I need to cover. What we are going to talk about is the classic data analytics workflow, which begins with somebody saying, look, I have some business problem, and somebody goes, finds the data for that and analyzes that, puts it together in the form of a chart. Somebody looks at it and says, yeah, no, make these changes. And finally, it goes back to the business user who says, based on this, here's what I'm going to do. And then they come back with a whole bunch of new questions. This is hardly a linear process. There's a whole bunch of loops that we jump around through the whole process. But what we're finding is that LLMs are at every stage of this workflow able to pitch in some shape or form. And what we'll be covering today are some of the ways in which LLMs are already helping. This is not intended to be comprehensive. If you get one or two ideas from this, that in itself may prove pretty helpful. So I'm not going to try and complete all of this. Therefore, if at any point any of you have questions around, wait, how can I do this? Or are there any tools that will help me do this? Wait, what are you doing there? Can you help me do that? Just jump right in. No need to raise your hands, just speak up, or feel free to raise your hands, whatever. But the more you interrupt me, the more this session will be yours. So please interrupt me. Let's start with finding the business problem. Now, it may come as a surprise, but okay, there was this bank, which once reached out to us and said, Anand, we want you to help us with an engagement. We have a budget and the budget is fairly sizable. We'd like you to help solve some data analytics problems. So we said, great. What problem would you like us to solve? They said, we don't really care. What? They said, see, this is October. We have 2 months before the end of the year and we have a data analytics budget. If we don't exhaust it, then it's going to go away. And the next year people will say, why do you ask for so much? So they'll cut our budget. So we have to spend it. We are also being given an incentive to spend on data analytics. So we want to spend on data analytics. We don't really care what problem you solve. So what am I supposed to do? We actually let go of that engagement, saying, you don't know what problem we want to solve, then how do we know what problem we want to solve? But this is not uncommon. A lot of people say, oh, data is supposed to be an asset. Okay, what are we supposed to do with it? Not sure. Our teams have this problem. In fact, our teams often have the problem of, what do we pitch to clients? And our solutions team say, oh, look, here are 100 solutions that you can pitch to the client. Say, okay, now I have a bigger problem. Earlier, I didn't have anything to pitch. Now I have 100. I would rather have just 1 or 2 things to pitch. This is one of those problems that LLMs solve pretty well. And let me show you how we do that. This is our list of solution offerings. So there's this one page where each one of these is a detailed offering where it can do all kinds of stuff. rather than figuring out from this what we should take to a client. Here's what our sales team does. They say, okay, I'm meeting the head of finance at NTT in Singapore. What can I show them? By the way, they mentioned, are you able to see this from the back? It's clear enough? Okay. They mentioned they were particularly interested in risk management and contracting. Now, what that does is takes all of these case studies, sends it over to the LLM, not exactly all of them, but a reasonable chunk of the relevant ones. And we have a set of demos. So now the sales team member just says, what I can do is tell you about auto loan defaults, I can tell you about contract analysis, I can tell you about vendor consolidations, all of which are relevant case studies, and then click on any one of those and then go into the details of that particular demo, and voila, you have a solution ready. Fairly straightforward. I mean, all you have to do is take a bunch of documents, put it into ChatGPT, ask a question, get an answer. But what people often miss is that you can do this for data analytics as well, except that what you dump are not documents. What you dump are data sets. But hold on, aren't data sets large? Half the reason why people reach out is that there's too much data. So we need some mechanism of figuring out what can be done with that variety of data. Well, one of the simpler ways is you don't need to pass the data to the LLM. You just need to pass the schema to the LLM or the names of the columns. You say, I have this spreadsheet that has these columns, I have this database that has these tables, and these tables have these columns. Take that bit, dump it into an LLM, and have it figure out what can be done. So that's an example of something that is quite easily doable. Let me show you. I recently conducted an examination, and this is the result of that examination. It's a quiz that about 660 odd students had taken. I know the time at which they submitted the exam. I know their email IDs. I know their total score against a maximum score, and their scores in individual questions. That's one data set. I don't know what business problem I could solve. As a teacher, what might I be interested in? Here's one way of solving that, and I'll show you a tool that we quickly put together, and then I'll show you how that gets built. Let's reload this. I'm going to upload the data set that we just picked, and right away you get a bunch of sample questions. So it says, I can find out what is the average total score achieved by students in the quiz. How many students scored the maximum score in the quiz? Which question had the highest average amongst all of these students? And so on. And these are relevant questions. I am certainly interested in how many students submitted their result for each type of quiz. I'm certainly interested in what is the highest average score by each grouping. How do we go about doing this? And or what if we had a database, something far more complex than that? The same procedure would still work. The mechanism behind this is, firstly, when we take any data set, we can convert it into a table of some kind. And the table structure in this case looks like this. There is a table, TDS ROE results, which was dynamically created when I uploaded this file, which has an ID, which is an integer, a submitted timestamp, which is an integer, it has a quiz ID, and so on. So we know all the fields that are there in that table. We also know some details about the individual fields in the table. Given this column name, some of them are integers, some of them are text. We know which of these are not null, which of these are default values, what the primary keys are. We even have some examples of the values. So the prompt that was actually sent to this LLM, let me show you what that looks like. History, yeah, data chat. This is the actual query that was sent to the LLM. Suggest 5 diverse, useful questions that a user can answer from this data set using SQLite, and you pass it the schema. Nothing more than that. And you have a series of questions. So this is another way in which we are helping the user figure out what problem they want to solve. The next time somebody says, oh, I have data, I'm not sure what to do with it, don't bother thinking too hard. What is easier is to help the user figure out the answer themselves, because they usually know what they want. Set them up with a system where they can dump their data set and it will prompt them, and they can start playing around with it, iterating on it. All you need to do is extract the schema. Let's go further, but before I go ahead, any questions? Let's move on. Yes, please.
Like you don't really want to dump your data set into some unknown large language model, right?
Good point. What if the data is confidential? I do not want my employee data set to go into OpenAI's data set. Very true. And this is the reason why most enterprises have blocked ChatGPT, Gemini, Anthropic, and the likes. Not only have these been blocked, internally there is now something along the lines of a detailed audit, not just of large language models, but of any AI use case, saying, is this something where we are allowing parties that should not have access to the data get access to the data? What are the possible solutions for that? One possibility is metadata. We can look at what we are sending the LLM and ask, is this confidential? Are the names of the tables confidential? Are the names of the fields confidential? In some cases, they are. Supposing Elon Musk is planning to launch a rocket to Mars, and if one of the columns names is planet, then you know that he's targeting multiple planets. So that is something you may want to keep confidential. But in the vast majority of the scenarios, metadata is usually safe, not just to send to an LLM, but in fact to send publicly. Second, you ask yourself, is this an LLM that is outside the provider that holds my data? Supposing your emails are on Google, then using an LLM provided by Google is probably about as safe, because you're trusting them with your data anyway. If you're, let's say, if you're using OneDrive and your entire organization's shared folders are sitting on OneDrive, it's a reasonably safe bet that you can trust Microsoft with your data, because you're already trusting Microsoft with your data. And they've also, organizations like Amazon, Microsoft, Google, they've gone to great lengths making sure that there are contracts and audits in place that prove to anyone who needs that the data that you're sending is not used to train those large language models. However, not everyone is aware of this. There is a backlash because people have, let's say Samsung about a year and a half ago had a data leak. As a result, Samsung shut it down. This was in the news. As a result, several organizations followed suit, and a year and a half later, we are still in that situation where people on the margin are saying, let's go slow. The more progressive organizations are doing this in a more nuanced way. Please feel free to interrupt me with questions at any point.
How about running an LLM locally?
You could run an LLM locally. There are 3 problems with that. The first is cost. The cost of running an LLM locally is humongous compared to running an LLM on the cloud. How much higher? Let's take an example. Let's take a look at the pricing of any LLM. So this is the current, this is a chart that shows the current state of LLMs. The x-axis is the cost per million tokens. The y-axis is roughly the quality of a large language model. One of the best LLMs that we can run today is the Llama suite of models. I have Llama 3.2, but yeah, let's take this one, Llama 3.1 Nematron 70B instruct. Now that's a 70 billion parameter model. Running that on a GPU would probably cost anywhere between $50 to $100 per hour. The cost per token here is 35 cents per million tokens. 1 million tokens is roughly all of the Harry Potter books put together. So what that means is, if you send 3 Harry Potter books, that's $1 at this kind of pricing. If you send, let's say not, yeah, that's about $1. And if you send 150 Harry Potter books every hour, right, Harry Potter series, that's when you would break even. The problem with that is one GPU cannot handle that kind of load, not in an hour. You would actually need 50 GPUs to handle that kind of load. So it's impossible to beat the cost of a service provider. Not just impossible, it's impossible by a factor of 50, and that factor keeps growing. So cost is not reasonable. Second is parallelizability. Sometimes you have 10 people accessing the LLM. You don't want to put them in a queue, which means that you need 10 GPUs. GPUs are scarce. So getting a GPU machine today, you need to wait in a queue. And eventually that problem will get solved, but we're still not there yet. So we probably have 3-4 GPUs. Suddenly there'll be a spike and there'll be 30-40 users accessing it, and they'll all stand one behind the other, and these take time. That's another problem. Third, the vast majority of organizations don't know how to set up a local LLM. The vast majority of organizations don't know how to set up a local language model, at least not for production. They can set it up on their own machines. So we have that as an issue, which is not to say that it's always a bad idea, just to say that 99% of the time, not worth it. Again, please just keep the questions coming at any point. So finding the right data to solve a problem is not such a big deal, because you ask a question. I mean, we can run the exact same process in reverse, and given this kind of schema, the LLM will be able to figure out what columns it needs to get the answer from. Not just that, it should be able to construct the SQL query to solve the problem as well. So supposing I picked this question, okay, or yeah, who scored the highest on question 3? What this should be able to do is figure out from the schema what the query is that it needs to run, actually execute that query, and give me the answer. So it turns out that question 3 carries up to 2 marks. And here is the list of students who scored those 2 marks in question 3. And the query seems perfectly reasonable, which is select the email. Yeah, select the email as well as the answer to that question, the score on that question from that table, where the score equals the maximum value from that table. Which means that if you can ask a question, it can figure out how to get the answer from the right data. And therefore, data analysis is largely moving away from the realm of what an analyst needs to do. You don't do the analysis, you get the system to do the analysis. This is something that is even more powerfully done with the likes of ChatGPT's code interpreter. Some of you may have tried this, but if you haven't, then do give it a shot. In the attachments, you can attach any file. I'm going to attach the same file that we have and ask the same question that we just asked, which is who scored the highest on question 3. And watch how it approaches this. It begins writing a Python script. It imports pandas, it says here's the file, I'm going to read the file, it's finding out the highest scorer in question 3, and it's made an error. There is no such thing as question 3. So it says there's no blah blah blah, so let me inspect the file structure to find out the correct column name. It doesn't give up. It continues and then looks at the structure of the file. It reads the names of the columns. It's basically reading the first 5 rows. It knows that these are the columns, and now it figured out that question 3 is actually called this particular whatever. Now it gets the value and it returns the result. Now incidentally, it's returning only one result because it thinks that only one student could have scored the highest value. It's made a mistake, but it's a reasonable mistake that an analyst might make. So I just let it know that multiple students may have the same highest score, and yeah, no surprises here. I'm fairly sure it will get this part right. Blah blah blah. Okay, and it's gotten a series of results and is displaying that as a table, which is going to be a long one because lots of students scored full marks on that particular question. Now, the thing to recognize here is the model was able to correct itself, and that's called agentic behavior. People are gently narrowing down to the definition of what agents are. It's still out there in the open, but one of the more popular opinions is where agents are things that try and figure out how to solve the problem by themselves. You don't have to give them that direction. Put more specifically, the control flow of a program is determined by the LLM. In this case, maybe the flow was something as simple as, here's the question, try an answer and keep trying until you get the answer right, or keep trying until the program is executed correctly. That's a simple example of an agentic workflow. Fair enough. You could have something more complex, like get the result, test it against a set of criteria. If any of those criteria fail, then fix only those criteria and revert, or check with an external system to see if the results are valid. Any of these are possible. We don't really understand how agents will evolve over time, but what you're seeing in ChatGPT is just one kind of agent which is able to write a program, get the result of a program, and correct itself as required, which is helpful. So what that means is it can also analyze the data. Let's get to a tool that can combine all of these. A year ago, Microsoft released a tool called LIDA, not sure how to pronounce it. Let's assume it's LIDA. And what LIDA does is, let me give you an example. You can upload a file. I'm going to pick the same file. And first, it does some analysis and generates a summary of what that data structure is. We'll give it a minute. In a few minutes, what we'll also do is look at the kinds of prompts that it's serving up. This seems to be fairly slow. Hoping there's no error. No, it's still just thinking a lot. And now it's created a summary. It says, here are the kinds of columns that we have. Next, it's trying to figure out what are possible goals of my exploration, meaning what are the kinds of questions that we could ask, like we saw earlier. Let's go back. One of them is, what is the distribution of total scores achieved by the students? How do the responses correlate with the total score? That's an interesting one, and so on. What it then does is starts creating the visualizations for these. So this is the answer to the question, what is the distribution of total scores achieved by students in the quiz? And yeah, that's the kind of pattern. Very few students have scored the highest mark, but this is a bimodal distribution, which is a somewhat unusual one. It typically indicates that there's some kind of cheating going on, or there's mixed populations. And yeah, I know exactly what happened in my class, but that's another story. This is a fairly typical pattern and a fairly typical analysis that came out without me having to ask that question, without me having to do the analysis, without me having to visualize the results. Let's ask another question. How do the responses correlate? This is another question that And I had thought of at some point, but never really got around to doing the analysis. Um, so I can't quite understand this chart too. Question to you all: how do you interpret this chart? What is it trying to do?
There should be a pin.
Should
Be pinned.
pinned.
Yeah. Pin.
Bin. Oh yeah, binning is probably a better idea. Yes, let's see if we can get it to do that in a few minutes. But any guesses on what this is trying to say? I see the Q3 all over the place. So okay, here's my guess. Um, the score can either be a 0 or a 1 or a 2. And for question 3, a lot of people have scored 2, and it's plotted it against their total marks. A reasonable number of people have also scored 0, but have on that question, the green one, but scored 4 as the total. In other words, what it's doing is a multiple scatter plot, not particularly effective. So let's ask it to refine this chart. This is not useful. Bin it, maybe. And the beauty of LLMs is, to a good extent, it doesn't matter how you put it across. The fact that we may not know the right words doesn't necessarily mean that it doesn't understand us. There is a chance that it might. And you're saying, okay, no, bin labels must be fewer than the number of bin edges. All right, let's try something else. Just calculate the correlations of each of these against the total, again, of each question against the total, and show it as a bar chart. That's easy enough for me to understand. So first question, how closely correlated is it with the total? Second, how closely correlated, and so on. This is interesting. I have never seen this before. There is one question which is slightly negatively correlated, meaning people who get this question tend to get the bulk of the other questions wrong, which is something over time. I'm going to go back and look at what this question is that seems to test a very different skill, because we need more of these kinds of questions. The correlation between the others is fairly close. And that leads us to another possibility, which is, what if we started looking at the pairwise correlations? If people score more on one question, does that mean they also score more on the second, the third, the fourth? Let's do that. So draw a heat map or whatever of the pairwise correlation matrix. Let's check that out and see what it works. Now you're beginning to see a bit of a pattern here, which is, you see an answer that provokes a few more questions. Say, okay, let's take a look at that question. Now, okay, the total score seems to be mostly, somewhat moderate to low correlation. We are looking for the dark blue ones, and yeah, something with LLMs that seems to have mostly a negative, addresses with LLMs has mostly 0 to negative correlation with most of the other questions, and something containing point also seems to have mostly low and negative correlation. But some questions I'm sure will be very strongly correlated. What are the highest that we can see that are other than 1 that are not on the, okay, that's analyzing something from, okay, getting some subjects from a CSV versus extraction from HTML. Those two questions are fairly correlated. Now, if they're very correlated, then I can drop one of those questions. They are roughly testing the same skill. So this is helping me figure out what questions I should drop, what questions I should have more of, without me having to know how to code, ask the right question, or do the analysis or the visualization. Currently, the ability to ask good questions is an art, but over time, it may not be. Any questions so far? Yes, please.
So for this platform, you need to upload a pre-processed data, right?
What do you mean by pre-processed data?
Because the original data that we receive, right,
Quite possibly. Correct. What if we treat that as another step in this process? Clean the data. You're saying, okay, clean the data, we have to do, everything else it can do. I would say, why? If the LLM is able to do all of the other stuff, we can have the LLM clean the data as well. Go on.
I think if we are cleaning, then most of the insights are already, you get most of the insights by cleaning the data because you do feature engineering and all that stuff. So
Fair point. By cleaning the data, we may be removing the insights, is what I hear you say. Is that correct?
no, you get a lot of insights by cleaning the data because you understand a lot of
Ah,
data. So maybe you don't need the visualization then.
you're saying that when a human goes through the process, they get a better understanding. Oh, very, very true. There was a time in the, let's say, late 1800s, early 1900s, when the physique of humans was far better than it is today. In every household, the lady of the household would take the clothes, walk all the way to the washerman or to the place where you do the laundry, spend a good hour of physical exercise making sure that the clothes were laundered. And then came the washing machine. We lost that skill. There aren't that many people who are unhappy about losing that skill. It's not about, it's in sense, health is great and it is important. That was one of the benefits. And today we effectively have to go to the gym instead to address that. We will lose a lot of things. But I doubt if many of those things that we lose, we value as much for their own sake. We usually value them because of what they give us. Health gives us longevity. If I can pop a pill, why not? The ability to understand data helps us get promoted as a data analyst, helps us come up with cooler insights. But if the LLM can solve that problem end to end, at some point, that the value of understanding data will diminish. Today, it is an important skill, but it is a rapidly depreciating skill. The LLM can understand the data. And this is a critical point that each of you needs to understand. LLMs are eating into domains that we used to consider our core competency. A significant portion of the work structure, the academic structure, they are all built on teaching people a set of skills, a large number of which LLMs have eaten into, a large number of which LLMs are going to eat into, and we don't really know which. So one of the smartest strategies that you can do is invite the LLMs to your table right away. Whatever it is that you're doing, check if an LLM can do it. Some it will. Great. Keep doing that. Some it will not. Write it down. And that's important because what you will then start doing is maintaining an impossibility list. A list of things that are currently impossible for LLMs to do. Keep checking that list every month because the speed at which that impossibility list vanishes is crazy. 4 months ago, what was on my impossibility list was LLMs cannot draw a Calvin and Hobbes comic strip. They just cannot. Let's look at how that has changed over time. The models have evolved rapidly. Let's see. Hope I can. Here we are. So if we take some of the models that, this is one of the classic open source models. The prompt that I gave it is a Calvin and Hobbes strip. Calvin is boxing Hobbes with a dialogue bubble from Calvin saying, bring it on. This is what it drew. That's not Calvin, that's not Hobbes, the text is meaningless. Then there was a slightly better model that was released, and yeah, that's kind of the style of Calvin and Hobbes. You see the tigerish thing, but wait, that's Calvin and Hobbes combined into one character, not quite as good. DALL-E, yeah, no, nowhere near my instructions. Then came Runway ML, no, not quite there. Imagen 3, and that was like, wow, okay, this kind of gets Hobbes right. Calvin has 3 hands, which is bizarre. The text is weird.
Tails. Yeah, 2 tails. Yeah.
Yeah, and two tails. Yes, that sort of thing is, yeah, it kept happening. And then DALI 3, which was supposed to be great, but now here's the thing. DALI 3 managed to get the text right. At which point I said, okay, here's a model that at least occasionally starts giving me text properly. That was a big breakthrough, because one of the things on my impossibility list was you cannot get an image generation model to write any text. You have to write the text yourself. That was falsified about 5 months ago. Ideagram, flux.dev, and this is not bad. That's not exactly Hobbes and that's not exactly Calvin, but the text is good enough. Moved on, and then I tried it out on ChatGPT Plus, and this is like, yeah, that matches it. This was about 3 months ago. So effectively, on my LinkedIn posts now, I've stopped posting any image other than just Calvin and Hobbes. And the beauty of it is today you can create an entire strip. Let's take my most recent one. This is 100% LLM generated. Notice the spelling mistake. I could not fix it. I absolutely could not get it to spell geniuses correctly. But this, I mean, to the point where one of my friends said, how do you manage to find the right Calvin and Hobbes every time? I'm not finding it any longer. Maintain that impossibility list. The set of things that you think an LLM cannot do today, it's just a matter of months before some of those start becoming possible. And then you will find that the bottleneck is your imagination. You can't figure out what is the next coolest thing that you can build. Let's proceed with this. Okay, actually, there's more to this. Now, LIDA also can explain the chart to you. Sometimes you saw that chart that it created, that scatter plot thingy, right? What I could have done was just passed it either to LIDA or even to ChatGPT and just said, explain this to me. And it does a pretty good job, which means the role of that project manager, okay, and here it's saying the chart comprises of two visualizations, a bar chart. There's a bar chart. Oh, okay, it's probably thought of this as a bar chart and a heat map. It uses this palette, blah, blah, blah. Step by step, it's figuring out what exactly it's doing in this, enough for a data visualization expert to understand the chart. Have a chart that you can't quite figure out the name of, pass it. Not only will it tell you what it is, but probably tell you how to create it as well. Let's try that, actually. Let's take Xenographics is a site that has some, yeah, as it puts it, weird but sometimes useful charts. Let's pick something that looks nice. Yeah, I'm going to just pick solar correlation. No, that just looks like, yeah, let's take this one, scatter pies. And okay, yeah, scatter pies. I may not spect element. Yeah, that is right. So let me copy this image, pass it to ChatGPT with the question, or actually, I'm going to pass it to Claude.ai. Because if you haven't tried this particular feature of Claude, you should. What it can do is create code. It can write code that you can run. So I'm going to write write D3 web app that creates this chart. Use vanilla JS, no React or other frameworks. Just create a simple application and run it. Now, here's where two interesting capabilities start coming in. The first is vision as a capability. Earlier, LLMs could read. Now they can see, they can hear. It's setting up the HTML, it's writing the code, blah, blah, blah. But it does not generate the artifact. So I will tell it, generate this as an artifact. Artifacts are a feature of Claude where it'll write the code on the right hand side, and you can just, like any copilot, start editing the code saying make this change, make that change. But there is another beautiful feature of this which for some reason seems to be disabled for me, where you can actually see the output. So instead of artifacts, which you should try at home absolutely, I'm going to use something that I built for myself which has the same capabilities. I'm going to save the file that we just picked and call it chart, .png, save it, use that as my design, not cardiac, chart.png, and give it the same prompt that I had given Claude, which is, or let's draw this chart using d3.js, and let me pick Claude 3.5 Sonnet as a model and run this. So it's doing more or less the same thing, but just for your information, you'll notice that it's explaining a bit about what I want. This particular technique is called chain of thought. I will come back to this in a few minutes and explain what it's doing. But on the right, it's creating the code for the chart. It's taking its own sweet time, but using D3 in great detail. No idea if this much volume of code is going to get right or not, but let's see and see how closely it manages to get it right. Okay, so it managed to get as far as the axes, but it failed with something here. Now, this is where the expertise of a human can augment the expertise of an LLM. You could say, look, the problem here is it's not imported D3 correctly. So I can tell it how to import D3. And I guess I have some code somewhere on how to import from CDN D3 at CSM. Is that it? No. Let me just check how I would import. Now, where would I have imported D3? In contract analysis script. Yeah, so this is a reasonably good way of importing D3 based on what I know. Import D3 like this and give it the hint that it needs to fix that problem. Now it's revising that same code to fix this particular issue, iterating. I mentioned that I would explain this chain of thought bit. One of the things we find is that when an LLM rambles, it tends to do better. Now, why is that? Imagine asking someone, you have to write an essay, but you cannot press backspace or delete. Just keep typing. Think about how hard that is versus something where you can press backspace or delete. Now, an LLM has no way of undoing what it's doing. It just has to keep typing, and that's hard. And people are now working on ways by which we can give LLMs the ability to correct itself. One of those is something you may have seen as the O1 series of models in ChatGPT, O1 Preview, O1 Mini. What they do is they try different approaches, and if one doesn't work, they backtrack, try another approach, and so on. A simpler way is just to tell it, think step by step. It's a specific prompting technique called chain of thought, and still not there, but what chain of thought does is gives the LLM a little more room and time to think. That often helps it write some stuff and later on look at what it's written, correcting itself if required. This still didn't work. So let's go back, correct it, and or what we'll do is try something simple. Keep it simple and ask it to rewrite the code from scratch. Works great. If not, we just picked too complex an example, and this would go into my impossibility list saying this particular kind of unusual chart, a scatter plot that contains a pie chart, is still beyond the capabilities of the LLMs today. My guess is this is 2 months away from being fixed. Okay, it's still rendering. But that is therefore a new capability. Oh, yeah. Okay, so not 2 months, 2 minutes. Yeah, these things keep happening. You suddenly see an impossibility turning into a possibility, and then you realize, okay, maybe I'm the dumb guy. It actually knows its stuff.
You might just show the original side by side.
Oh yeah, okay, yeah. So it kind of got the positions of some of them right, kind of got the colors right, didn't put in as many, but I did tell it to keep it simple. New sales, the axes are correct. Part of the legend it didn't get the shipping cost bit. Pie chart on scatter plot, it got the title right. So
How would you be able to tell whether it's a hallucination?
how?
How would you be able to tell whether it's a hallucination?
Whether it's a hallucination. Um, there are three ways these days that people are detecting hallucinations. One, an expert looks at it. I say an expert because LLMs are now beyond the point where someone not familiar with the domain will be able to spot a hallucination. An expert in the field will be able to do that. That is a good but expensive way of doing it. A second method that is becoming popular is broadly called evals. That is, you write a series of test cases. You say, for instance, let's take a standard test case that I have, which is take a simple string, what is 2 plus 2? And I write a program that says, when you get the output, make sure the string 4 is part of the output. It's a basic one. Or let's say we are asking the LLM to create a chart like this. What I could do is from the chart code extract whether the word new sales is present. If I could write better code, I would write code to check if the new sales was part of the x-axis, whether new profit was part of the y-axis. And when I write enough such test cases, I'm reasonably sure that my prompt is working, and over time, as my test cases grow, I become more and more confident. So if there's a new model, then my existing set of test cases can be run on that new model, and I will have confidence that that's working fine too. This is also expensive. It may be more expensive in the short run than having an expert do it. But if you're doing this repeatedly, it's less expensive. The third method, which is gaining popularity these days, is LLM as a judge. You pass it to another LLM and ask it to compare. So let's do that. Let's take this chart and yeah, let's take this chart, go to ChatGPT. Don't I already have a ChatGPT window? No, I don't. Okay. ChatGPT. Paste it and take the original image and paste it, and then say one of these is an original, the other is an LLM generated copy. The one with fewer objects is the copy. List all the mistakes the LLM generated copy has. And if there are none, it will probably say none, or it may even identify small ones, but okay, the one with fewer objects. So it knows that it's gotten fewer data points. The shipping cost legend, which was on the top right, it completely missed. Correct. Scale of bubbles appears to be inconsistent. I would not have been able to spot that. Cluster distribution, it doesn't recreate the clusters. Access labels, oh, but the LLM copy simplifies the representation of data without preserving the nuances. Okay. I'm not sure. Oh, I think it means there's, okay, the zero. Okay, I'm not sure what this means. So the judge in this case may be hallucinating, or I may be hallucinating, I'm not sure. But that's one of those things where increasingly we are not sure if the expert or the LLM is better in many fields, which is good because then you can start bringing in the LLM as a judge in many areas. They're reasonably good compared to an expert. And that is increasingly becoming the most cost effective way. In short, how do we prevent hallucinations? Ask another LLM to cross check. Yes, please.
When you told it to keep it simple, is that a prompt? Is that a name for that prompt?
I'm no longer sure. Let me explain. What I'm finding is that a lot of things that used to be common sense are now being called prompting techniques. And a lot of things that are prompting techniques, a lot of people have started just absorbing as part of their normal style of conversing with LLMs, including me. So keep it simple is something that I have an intuition about. Having worked with LLMs day in and day out, I know that it will help in some way. It's kind of like 25 years ago when Google came in. People weren't really sure how to search, and they would start putting in a question. And then they realized, okay, putting in keywords for matches is the better way. Now it's the exact opposite. We have to go back to the keywords matching. But for a person who gets an intuition that this is how you do it, I guess you could say, yeah, they're prompt engineering. But more often than not, I would not say that it's a specialized thing. And the reason I'm saying that is what I would put under the umbrella of prompt engineering is stuff that has papers written about. If there's enough research that shows that something like chain of thought, the phrase, think step by step, consistently works across models, consistently works across scenarios, and has been tested by many people, and for all of them, it's produced good results. That is a prompt engineering technique, and it's also not something that people would have necessarily guessed is a good idea. Giving LLMs a personality, you are an expert chart maker, is generally considered good advice. Again, consistently tested, works fine in many scenarios. But keep it simple. Will it oversimplify? I don't know. I haven't tested it. In this case, it created a bunch of hallucinations. On the margin, is it worth doing? Is it not worth doing? I just have some kind of an intuition, which means that it probably works for me 60% of the cases for my scenarios, not a prompt engineering technique. Okay, so since we are in the realm of evaluation, let's talk a little bit more about how we can evaluate these kinds of things. I showed how you'd be able to use an LLM as a judge, and that can include evaluating charts, comparing charts, and the likes. But you can use LLMs as a judge in so many other ways. Let me show you one particular scenario. One of our clients is a pharma company. They said, we want to identify whether something is an adverse event. Let me explain. A patient who is part of a study puts in text like this. I've been taking this medication for 3 weeks. 10 days ago, I had severe joint pain in my knees, and I can't climb stairs. I don't have arthritis or any such thing. Maybe this is a side effect. They get dozens of messages like this, and they have to figure out, is this something that might be because of the drug they're taking or might not be because of the drug that they're taking? If you just ask an LLM to do this, sometimes it gets it wrong. Let's take an example. No, this may not be the best example. Let me reload. Pick another one. Yeah. Let's do this analysis. So, the first LLM that did the analysis was simply told, here's some text, figure out if it's an adverse event or not. So it says, in this case, and let's look at the text. I felt unusually fatigued and am struggling to work, but I also started intermittent fasting last week. Maybe that's why I have low energy levels. I'm not sure if the medication is contributing to the fatigue. The first LLM says, look, there's fatigue that's reported. He can't focus on work. There's a recent change in diet that may be a factor. He's not really sure. But overall, I would say, therefore, this is an adverse event. Here is another LLM which has been given slightly more detailed prompts. It's roughly been told, think step by step and then come to an answer. So it says, okay, this symptom reported, yes. Does this correlate with the medication intake? Now it came up with the criteria by itself. And it said, no, it's not really correlated with the medication intake. Also, is there a causal relationship? No. So it concludes that there is no adverse event. So now we have two people independently saying yes and no. We then pass the results of those to a judge. Now the judge has been given a far more detailed prompt, a specific series of steps on how to evaluate it. So it first evaluates, is there some temporal ambiguity or causality, which is one of the criteria. And based on that, it says, no, I don't see a clear temporal link. Interpretation of the symptoms is variable. It goes through a series of 9 criteria, comes up with its own result, which is not an adverse event. But what it also does is sends feedback. It tells the context analysis without revealing its own process, without revealing the question paper, so to speak. It says your analysis identifies key factors, but the conclusion differs from the details presented. Make sure that you are connecting the symptoms and potential causes clearly. Similarly, it passes the BioClin LLM some feedback. Yeah, you've done a good job. Great. Now, these LLMs then look at this feedback and decide whether they want to revise or not. They may or they may not. So this one looks at the details again and says, yeah, I changed my mind. It is not an adverse event. This one didn't need to change its mind and concludes that it's not an adverse event. In terms of flow, here's how it works. 2 different models pass their input to a judge, which gives them both feedback. They optionally revise it, and all of that comes back together and finally results in a pharmacovigilance assessment summary. Now, this is a legal document that needs to be sent to the regulators. It usually takes PhDs to put this together. This approach has given a result that is comparable, in some cases beating their quality at practically 0 time, practically 0 cost, and still going further. And this becomes possible because of LLMs being able to evaluate their work. When we are creating charts, when we are creating analysis, and you're not really sure if it's right, pass it to an LLM. It will solve that problem. Okay, we are out of time, so I'm going to wrap up on the last 2. We'll open up for questions. But you've also seen how they can, okay, you haven't really seen. I'm just going to talk very briefly about these 2 things. Once you have the results of an analysis, what are you supposed to do? So for instance, in my case, I find that there are some questions that are very highly correlated with each other. Should I just drop one of them? Which one? Ask the LLM. Not only is it going to be able to give me the analysis, it's going to tell me what I can do with the result of the analysis. And then what? Often, the LLMs can generate follow-up questions. My daughter and I share a ChatGPT account, and I once did a comparison of the length of her conversations versus the length of mine. I found that mine were much smaller, like 1 page, 2 pages, hers were 15 pages, 20 pages. How do you manage to ask multiple questions on the same conversation? I usually, when I get another question, I just go to a new conversation and continue to avoid polluting the history. And she said, when you get an answer, don't you get 10 new questions? No, I don't actually. And that's a problem. I don't actually get that many new questions. So in my system prompt in ChatGPT or custom instructions in ChatGPT, I have a specific instruction which I should be able to find. Yeah, settings. You may have seen this personalization queue, which includes custom instructions. And one of my custom instructions is, suggest follow-up. Suggest follow-up prompts for open-ended inputs. When I'm giving something broad, just tell me what else to ask. I'm not good at asking questions. You be the person that helps me come up with the next set of questions. And now my conversations have grown 5% longer, 10%. The problem is me, not the LLM. But that is something that LLMs are pretty good to. What I wanted to leave you with is one theme. Practically any workflow, and certainly the workflow of creating data visualizations, is getting disrupted. There's almost no element in that workflow which cannot be aided by an LLM. There are many elements in the workflow that can be automated and entirely replaced by an LLM. Think about what skills you're picking up. Think about how an LLM could augment that. And think about how you can augment an LLM based world that's coming up. Okay. Practice and wish you all the best. Thank you. I am happy to take questions, but I'm conscious of time.
That was an excellent. Please ask questions.
Yes, please.
Yeah. So on the theme of like those LLMs appear to be able to do like a couple of like part of the workflow. So recently I've been seeing all those like actually data analytics agents that like I don't know. I think a long time ago there was one called data interpreter, but I guess by now there will be many more new ones. Like what do you see is really like the state of the art where we are at right now, and for these agents, and like what do you think are the gaps in some of these agents that are worth fixing? Yeah.
Earlier, one of the gaps that agents had was they couldn't write good SQL. That's not a problem anymore. Or they couldn't write good Python. That's not a problem. What I mean by it's not a problem is you just saw what happened, right? I saw that chart for the first time, and I haven't been playing around with automated data visualizations much. But in 5 minutes, I was able to get it right, which means that a well-tuned prompt can solve that kind of a problem fairly easily. This was a problem, it's no longer a problem. But what's an example of a problem today? Supposing in that question that I asked, or okay, we have, let's take a look at the data set. Supposing I asked the question, okay, this is not a great data set for that. Let's assume that there is a column which contained city and another column that contained country, and I had IN, US, SG, JP, CN, BR, etc. If I ask the question, which students are from Brazil, how would it go about it? So first, it would say where country equals Brazil, and then it will get 0 results. So by default, it would conclude that there are no students from Brazil, which is not quite right. So it may, like ChatGPT did a little earlier, look at the list of unique values. But in the case of country, there are probably only 200 odd countries. In some other fields, there would be 25,000 unique values, and it won't fit in the context window. So it won't be able to solve that problem. For example, names. If it's a list of 100,000 employees, it can't get, let's put it this way. One of the questions I could ask is, who are Bill's reportees? And you would assume that when somebody just says Bill's reportees, Bill must be somebody senior. His actual name is probably William something. And we want to know their reportees. A human would be able to figure this out. For an LLM to be able to do this is hard. We actually deployed a solution for one of our clients in the HR space. And that solution failed exactly because of this problem. The question they posed was, who are Bill's reportees? No. And it was a basic question. So it's unable to extract values, it's unable to filter for categorical values. That's a classic problem that we are facing today. Joins are hard. I have an employee ID column in table 1. I have an employee ID column in table 2, except here it's called ID, there it's called employee ID. Is the LLM able to guess that they match? Often not, because table names are not well written. So one of the initiatives going on in many organizations is, how can I annotate my metadata so that LLMs can start understanding them? Increasingly, we are getting to an age where we are catering to LLMs alongside LLMs catering to us. So that's an initiative. If that works, joins might start improving. But data quality will start becoming a problem because I have employee IDs here beginning with E, but there is no E prefix in the other one. How do we solve that? We don't know. For the first two that I mentioned, at least we kind of know how to solve that problem. In this case, we would use embeddings. When we run a filter, you don't say equal to, you say get me an approximate match sorted in descending order of quality and use that to create a composite score. That sort of a thing is well understood today, but people haven't yet implemented it. In short, the problem of conversational BI is a fractal problem. What I mean is you solve one, the next one will open up. You solve that, the next one will open up, and so on. Until, at some point, we'll say, the vast majority of the problems are solved. Today, we are probably at that, let's put it this way, we are probably where Toy Story was in 1995. It was a huge breakthrough in computer graphics. That kind of quality, that cost, impossible. But there's no mistaking Toy Story for anything that's human related, and they specifically picked Toy Story because toys are easier to animate. Animating the hair of the princess in Shrek was a huge leap forward. Animating water in Moana was a huge leap forward. And all of these leaps are taking us to the kind of animation we take for granted today. It will take time. Not a clear answer, but quick answer is we can't do filters very well today. Yes, please.
Yes. So I mean, traditionally, data analysts meant being the SQL monkey. So now the SQL monkey skill set doesn't seem to be that useful. So yeah, what are we supposed to be training the data analyst for now?
I don't know. In the 1980s, if somebody had asked me, I'm a typist and I type documents, professional legal documents, and now there's this newfangled thing called a word processor. What am I supposed to do next? The only thing I'd have told them was start learning word processors, but is that going to be as large a market as the typist market? No. People would do self-service and serve themselves. I don't know what became of the typists. Absolutely no idea. So all I can say is please use LLMs more, but beyond that, who knows?
Plumber or a gardener?
Yeah.
Be a plumber or a gardener?
Yeah, no, and those will probably pay more than a data analyst over time. Yes, please.
Yeah, this whole talk was about automating data visualizations, right? But your whole process was not very automated. You had to like prompt. So you come from a very well-known and very booming business. So have you like implemented any truly automated data visualization processes in your company?
A process where the entire system from beginning to end is completely automated? Absolutely not. And this, we are currently in our fourth failed attempt of doing that. Today, we are not there. What we're seeing though is now is roughly the first time. When I say now, I mean the last 2-3 months is roughly the first time when every element of that workflow can be automated. Putting it together, no. Why is that? Because there is a level of quality that you need for automation. It just has to flow through seamlessly. Each of those steps works fine 80% of the time. I need 99% of the time for it to be automated. So I'm waiting.
Any more questions? If not, I want to put a huge hand of applause for Alan.
Thank you.